Welcome to this explainer. Today, we're going to completely decode the underlying engine that powers Bitcoin, and really the broader blockchain revolution as a whole. We're going to unpack exactly how digital trust is built from the absolute ground up, without a single bank in sight, using this brilliantly battle-tested system known as proof of work.
Just think about this for a second. How do you actually build a highly secure financial system with absolutely no banks involved? I mean, for centuries, we've relied on central authorities to act as the ultimate arbiters of truth, right? Removing that middleman entirely creates a massive vulnerability. Well, unless you have a completely flawless mechanism for decentralized consensus.
Okay, let's dive right into this. Here's our roadmap for today. 1. The problem of digital trust. 2. Inside the mining engine. 3. Incentives, rewards, and security. 4. The cost of proof. And finally, 5. The ultimate bottom line.
Starting with Section 1, the problem of digital trust.
Traditional centralized banking relies completely on trusted third parties, and that basically creates a huge single point of failure. If the bank's ledger is compromised in any way, the whole system fails. Now, the decentralized blockchain model completely eliminates this vulnerability. It allows literally anyone to verify transactions on a public, transparent ledger. But here's the catch. Achieving network-wide agreement without a central referee requires a truly radical security mechanism.
And that mechanism is proof of work. It's the consensus protocol that secures Bitcoin by requiring network participants, who we call miners, to solve these incredibly complex, resource-intensive cryptographic puzzles. I know computational puzzles sound super technical, but basically these computations do all the exhaustive heavy lifting of validating transactions and forging new blocks. It's mathematically ensuring trust, rather than relying on an institution to do it.
Let's move to Section 2 and see how this builds. Inside the mining engine.
So how does this engine actually run? Well, the mining process operates in 4 distinct phases. First, miners compete to bundle up all the pending transactions. Second, they race to find the correct hash. What that means is their specialized hardware is rapidly guessing random numbers called nonces at a rate of trillions every single second. Trillions. Third, that guess has to hit a super strict algorithmic difficulty target set by the network. And finally, when a miner actually cracks it, the new block is definitively added to the chain.
Now, at the very core of this security is the cryptographic hash itself. It acts like the ultimate digital padlock. Because this hash is entirely unique to the data inside a specific block, it creates absolute immutability. If a bad actor tries to alter even a single decimal point in a past transaction, boom, the resulting hash changes completely. The entire decentralized network instantly recognizes that the hash is invalid and just totally rejects the tampering.
Moving on to Section 3, incentives, rewards, and security. Now, what's really interesting about this is the brilliant game theory baked right in. The first miner to successfully validate a block actually earns a block reward. Because solving these puzzles takes massive upfront capital, for hardware and electricity, miners are financially heavily incentivized to just play by the rules. It perfectly aligns their purely selfish financial motives with the overall security and integrity of the entire network.
But it's not without its challenges. Let's look at Section 4, the cost of proof.
So the crucial point here is that this level of absolute security demands some pretty severe trade-offs. The first one, staggering energy consumption. The Bitcoin network notoriously uses more electricity than some mid-sized countries, which is just wild to think about. Second, you see massive bottlenecks in transaction speeds because global decentralization simply can't match the throughput of a centralized network like Visa. And finally, the escalating difficulty of these puzzles is pushing out the everyday individual miners. This creates rising competition from massive, centralized mining farms, which ironically kind of threatens the very decentralization the whole system was built for in the first place.
Which brings us to Section 5, the ultimate bottom line.
And this brilliantly illustrates that despite the undeniable friction of those immense energy costs and slower transaction speeds, proof of work remains the absolute most battle-tested security model in Web3 history. By successfully shifting trust away from centralized institutions and over to cryptographic math, it essentially proved that decentralized digital finance isn't just a theory, it's a functioning, highly secure reality that is genuinely capable of securing trillions of dollars in value.
So, as Web3 continues to evolve, we're really left with this ultimate tension. Does the absolute security of a trustless system actually justify its immense real-world energy demands? The debate is definitely far from over. Thank you so much for joining this explainer, and we'll catch you on the next one.